Hello everyone. So tomorrow we have discussed some S parameter topic. Now we are going to continue that S parameter. Okay. So tomorrow we have discussed S parameter and question discussion. So tomorrow we have discussed some question discussion of VSWR, and then after S parameter, a scattering parameter. Today we are going to discuss a scattering parameter, and tomorrow we will discuss some questions of scattering parameters. Hello. So today we are going to discuss some scattering parameter. In previous class what we have discussed this thing. This is a coupler. So I am going to revise in 5 minutes what I have taught in the previous class. This is a coupler, this is a scattering matrix. In that matrix, in that coupler, there is a incident wave and reflected wave. When you incident V1 plus, then there is a V1 minus, and transmitted wave is V2 minus. When you have incident V2 plus, then there is a V2 minus, and transmitted wave is V1 minus. So there is a diagram. The SMN is written like this. First one is for output, second one is for input. Here output is 2, input is 1, so S21. Here output is 1, input is 1, S11. Here output is 1, input is 2, S12. Here output is 2, input is 2, S22. So we have calculated like this. This is our S parameters scattering matrix diagram, and then after we have discussed that when port 2 is matched, then V2 plus is 0 because reflection coefficient is 0. So V2 minus is incident, V2 plus is reflected. So V2 plus is reflected since reflection coefficient is 0. So V2 plus will be 0. If V2 plus will be 0, then V2 plus put V2 plus is equal to 0. Then you can define S11 and S21. S11 is V1 minus upon V1 plus and V2 minus upon V1 plus. This one is our input reflection coefficient and this one is forward gain. So this one is forward gain, this one is input reflection coefficient, and it is also known as reflection coefficient at port 1 due to port 1 when port 2 is matched. So reflection coefficient at port 1 when port 2 is matched, and this one is transmission coefficient at port 2 but due to port 1 when port 2 is matched. So like that we have studied. Then after we have studied when port 1 is matched, then we have discussed that S22 and S12. S22 and S12, S22 is output reflection coefficient and reflection coefficient at port 2 when port 1 is matched, and this one is reverse gain because output is at input side and input is at output side. So we are getting like this. So it is a reverse gain, and it is known as transmission coefficient at port 1 due to port 2 when port 1 is matched. This is the condition when port 2 is not matched, it is mismatched. Then what will happen? What will be the S11 new? What will be the S21 new? What will be the S12 new? So these are the all 4 parameters we have discussed in the previous classes. Then after what we will do? Then after we will discuss that. What will happen? What will happen when it is reciprocal? What will happen when it is not reciprocal? What will happen if it is symmetrical, asymmetrical, or what will happen if it is lossless, attenuator or amplifier, and what is the condition with power, and what is insertion loss, what is return loss, what is gain. Then after this all terms we are going to discuss. After that we are going to discuss ABCD parameter in terms of S parameter and S parameter in terms of ABCD parameter. These all terms we are going to discuss. Then after we are going to discuss series network, shunt network, and then after T network or series shunt series network, you can do simply like this. So we are going to discuss all these things in a manner. So first of all we are going to discuss what? We are going to discuss the power condition. Power condition. What is the power condition? What is the power condition? So power condition is something like that. So S parameter in terms of power, S parameter in terms of power, in terms of power. We are going to discuss S parameter in terms of power. Tomorrow we will discuss question discussion of S parameter. Tomorrow we are going to discuss question discussion. Okay. So in terms of power, what you are going to define? First of all, this is our coupler. Yes sir, this is our coupler. This is our coupler. In the coupler, what will happen? In the coupler, if you incident power, then the power will be transmitted and some power will be reflected. When you incident power, that means Pi1, and there is Pr1 and there is Pt2. Yes sir. So this is the power. This is power. What is power? So we have defined power. So in terms of power, what is going to define? First of all, we are going to define what is S11. S11 in magnitude is nothing but it is a reflected power upon incident power, under root of reflected power upon incident power, and S21 is defined upon Pt2 upon Pi1. That means transmitted power upon incident power. So this is our Pi1 and Pr1. Okay. So after that we will discuss second thing, that after that we are going to discuss second thing. If incident wave is from this side, from second port, what will happen? So incident wave is from second port. Okay. So incident wave is from second port. So in case of second port, if you put second port, from second port, if you incident wave Pi2, then there is a reflected wave Pr2 and there is a transmitted wave Pt1. There is a transmitted wave Pt1. So you have S22. S22 is nothing but Pr2 upon Pi2, and S12 is nothing but Pt1 upon Pi2. So this is magnitude. This is not in the phase, it is only in magnitude. So this is the S parameter in terms of power. In terms of power. Then after, what we will do? We will define lossless, attenuator, lossy, everything. We are going to define lossless, attenuator, everything. Second case. So what we are going to do? First of all, I will define for lossless. For lossless, what is the condition for lossless? Because they may ask condition for lossless, condition for lossless. Then they will ask condition for attenuator. Then they will ask condition for reciprocal. They will ask anything. So in this case, you are seeing here that in this case, if you are incident 5 watt, if it is reflected 2 watt and transmitted 3 watt, so there is no loss in this device. So there is no loss in this device. 2 watt is reflected, 3 watt is transmitted, and 5 watt is incident. So 5 watt is divided into 2 watt and 3 watt. So no loss inside this coupler. So there is no loss. No loss. Loss is 0. Yes sir. Second thing is, if you are incidenting Pi1, yes sir, then it will be sum of Pr1 and Pt1. Yes sir. Then 1 is equal to Pr1 upon Pi1. Yes sir. And Pt1 upon what is Pi1. Yes sir. Then we have studied under root Pr1 upon Pi1 is S11. So PR1 upon PR1 is S11 square. PT2 upon PI1 is S21 square. So it is nothing but it is mod S11 square plus mod S21 square. So this is the condition for lossless. This is the condition for lossless. That means S11 square plus S21 square should be equal to 1. Similarly, you can put it here like that. You can think like that here also. You are incidenting 7 watt. Here reflecting 3 watt. Transmitting 4 watt. So what you are getting? This one has also no loss. This one has no loss. Yes sir, no loss. Then what will happen sir? So PR2 and PT1 is equal to PI2. Yes sir. Then we have PR2 upon PI2 plus PT1 upon PI2 is equal to 1. And we know that this one is S22 square and this one is S12 square. So this is the condition for lossless. So for lossless, S11 square plus S21 square is equal to 1, and for lossless, S22 square plus S12 square is equal to 1. So this is the condition for lossless, because there is no loss in this device. There is no loss in this device. Then we have going to discuss second thing. Second thing is for lossy, for attenuator. What is the condition for lossy? For lossy, what is the condition? So we are going to discuss what is the condition for lossy device. So for lossy device, what will happen? This one is something, this one is something, 2 watt is reflected, transmitted, or here 3 watt is transmitted. So what will happen? I am incidenting 5 watt, 2 watt is reflected, 2 watt is transmitted. So there is loss of 1 watt. There is loss of 1 watt. So what is the, there is loss? Yes, there will be loss. There will be loss. There will be loss. Yes sir, there will be loss. So here loss is non-zero. How much there will be loss? Loss is PL, and PL1 is equal to 1 watt. PL1 is equal to 1 watt. So loss is here 1 watt. I will ask what is the loss is here. So I am incidenting 7 watt, reflected 3 watt, reflected 3 watt. Yes, so here is also loss in the device, because there is a loss. So PL2 is how much? 1 watt. Yes sir. So what you get the condition? PI2 is equal to PR1, PI1 is equal to PR1. Yes sir. And PT1 plus PL1. PR1 is 2 watt, PT2 is 2 watt, and loss is 1 watt. 2 watt plus 2 watt plus 1 watt, 5 watt. 2 watt plus 2 watt plus 1 watt, 5 watt. So you are getting 5 watt. Yes sir. So PI1 is greater than how much? It will be greater than PR1 plus PT1. PR1 plus PT1. Yes sir. PR1 plus PT1. So we can say that PR1 upon PI1 is greater than plus PT1 upon PI1 is less than 1. Yes sir, it is less than 1. So I will divide PI1, this one plus this one should be less than 1. That means you can say that the magnitude of a square, this one is S11 square, this one is S21 square. So magnitude of S11 square or S21 square should be less than 1. How we are getting? Because there is incident wave, 2 watt and 1 watt loss. So that means PR1 plus PT2 is less than PI1. Yes sir. So their ratio will be less than 1. This one is S11 square, this one is S21 square. So that means it will be less than 1. Similarly, you can write it here also. that means Pi2 is equal to PR2 plus PT1 plus PL2, because loss is in the device. So PR2 is greater than PR2 plus PT1. Yes sir. So we have PR2 upon PI2 and PT1 upon PI2 should be less than 1. That means we have S22 and S12 square should be less than 1. So this is the thing here. So this is for lossy device. This is for lossy device. Which part? Lossy device, not for lossless. It is for lossy condition. So lossless condition is it is equal to 1, and lossy condition is it is less than 1 and less than 1. Then after we have amplifier also. What is the condition for amplifier? So for amplifier we will see. What happened with amplifier? This one is equal to 4 volt. This one is equal to 4 watt. Yes sir. This one is 4 watt. Yes sir. And this one is 5 watt. This one is 5 watt. Yes sir. So what you see here, this one is input is 5 watt, output is 6 watt. 4 plus 2 6 watt. And here input is 7 watt, output is 3 plus 5 8 watt. So output is 8 watt, input is 7 watt. Input is 5 watt, output is say 6 watt. So what will happen here? There is a gain in this device. How much gain in this device? In this device there is a gain of 1 watt. How much gain in this device? In this device there is a gain of 1 watt. So what is the condition for this one? For this one, input power is less than reflected power plus transmitted power, is less than reflected power plus transmitted power. That means PR upon 1 PI1 plus PT2 upon PI1 is greater than 1. That means S11 square plus S21 square should be greater than 1. This is the condition for amplifier. Similarly, PI2 is less than PR2 and PT1, and you can assume that PR2 upon PI2 and PT1 upon PI2 should be greater than 1. That means S22 square and S12 square should be greater than 1. This is the condition for S parameter. So this is the condition for S parameter for lossless and for lossy and for amplifier. For lossless, what is the condition? What is the condition for lossy? So for lossless, condition is S11 square plus S21 square is equal to 1 and S22 square plus S12 square is equal to 1. And for lossy it is S11 square plus S21 square is less than 1, and for lossy S22 square plus S12 square is equal to S22 square plus S12 square is less than 1. Yes sir, this is the condition for lossy. Then after amplifier, it is greater than 1 and this should be greater than 1. So you will analyze anything, you will analyze these all parts. Then after I will write a summary point so that you will understand everything. So what is the summary part? I will divide into two parts. First part is port 1 and second part is port 2. For port 1 I have to check separate, and for port 2 I have to check separately. So port 1 and port 2 I have to check separately. I cannot check in with them only. So this is the point here. So this is port 1. Yes sir. Condition for port 1. This is the condition for port 2. First one is for lossless. First one is for lossless. What is the condition for lossless? First one is for lossless. Second is for attenuator, that means lossy. Attenuator or lossy. And third is for amplifier. Amplifier. So first port is lossless only when S11 square plus S21 square should be equal to 1, and second port is S11 square plus S21 square should be less than 1, and S11 square plus S21 square should be greater than 1. Similarly for port 2, S22 square and S12 square. Someone will write S22 square and S21 square. Wrong. S12 with S22, S12 with S22, S12. Always try to remember. S22, S12 is there, and for S22 square and S12 square is greater than 1. This is less than 1. So this is the condition for port 1. Port 1 is lossless with this condition. Port 1 is lossy with this condition. Port 1 is amplifier with this condition. Port 2 is lossless with this condition. Port 2 is lossy with this condition. And port 2 is amplifier with this condition. So this condition is very, very important, because this question is not asked in GATE exam. They may be asked this question in GATE exam. Why? Because this is a very good question, and in S parameter they always ask new question. So they always ask new question. So in new question they will ask this question. Okay, in S parameter they always ask new question. Second thing is what is the condition for ABCD? What is the ABCD parameter in terms of ABCD parameter in terms of ABCD parameter in terms of S parameter in terms of ABCD parameter. So we are going to define S parameter in terms of ABCD parameter. This is very, very important equation in terms of ABCD parameter. ABCD parameter, or it is known as transmission line parameter also. So S parameter in terms of ABCD parameter. What is the equation? You have to remember. First one is S11, second one is S12, third one is S21, fourth one is S22. What is the equation? So for that I have, first of all I will remember denominator, because denominator is same for all cases. So B into Z naught, C by Z naught, sorry, one second, V1, I1, A V2, B I2. So B will be B by I, impedance. B will be impedance. Okay. So B by Z naught. C into Z naught plus D. This is the point. You can remember this point. So the denominator will be same for all four cases. Denominator will be same for all four cases. All four cases. Okay. Denominator will be same for all four cases. Then we have A, B by Z naught and C Z naught plus D. One second, I forgot this formula. One second, I will see. You have to remember this formula. So C minus D. C minus D. Second one is S11 and S22. There is a difference. That what is the difference? Difference is A will be minus A, B will be same, B term will be same, B by Z naught, and minus C Z naught plus D. So you can remember S11 and S22 by separately. You can remember S11 and S22 by separately very easily. Yes sir. Very easily. One has A plus B minus C minus D. Here A will be minus, D will be plus. Like that you can remember. Then after you can remember the formula S12. S12 is 2 AD minus BC. AD minus BC, and here it is 2. So this is the formula for S parameter in terms of ABCD parameter. So you have to remember this formula. You have to remember this formula. This is the formula for ABCD parameter in terms of ABCD parameter in terms S parameter in terms of ABCD parameter. Okay, then what you will do, then one formula is also you have to remember, that ABCD parameter in terms of S parameter. Second one is ABCD parameter in terms of S parameter. So you can write down this formula. It is very important formula. It is very important formula. Okay, then we have second one is ABCD parameter in terms of S parameter. ABCD parameter in terms of S parameter. You have to remember this formula. What is the formula for ABCD parameter? So A, then we have B, then we have C, then we have D. Then we have a denominator. In denominator, what is 2s21? 2 times of s21. 2 times of s21. Yes sir. It is very easy to remember. Then after here also 2 times of s21. 2 times of s21 means denominator will be going to same. Denominator will be same. So this one denominator is going to be same. Then after we have what we have 1 plus s11, 1 plus s11, 1 minus s22 and plus s12 s21, s12 s21. Yes sir. And for D, 1 minus s11, 1 plus s22 and s12 s21, s12 s21. Yes sir. Then after for B, it will be 1 minus 1 plus s11. Yes sir. 1 minus 1 plus s22 and 1 s12 s21, and then we have 1 minus s11 and 1 minus s22 and s12 s21. Yes sir. B is in terms of impedance. B is in terms of impedance, C is in terms of admittance. So B will be multiplied by Z0 and C in terms of admittance, so it is divided by Z0. So this is the formula for S parameter, ABCD parameter in terms of S parameter. So this formula is for S parameter in terms of ABCD parameter. This formula is for ABCD parameter in terms of S parameter. Because if you know ABCD parameter, you can calculate Z parameter. If you know ABCD parameter, you can calculate Y parameter. You can calculate H parameter, G parameter. So you can calculate, because you have studied in two-port network. I have taught this two-port network in YouTube. There is a separate playlist for two-port network. You can go through and you can study. So if you know ABCD parameter, you can calculate Z parameter. If you know ABCD parameter, you can calculate so Y parameter, H parameter, G parameter. You can calculate everything. And if you know Z parameter, then you can calculate ABCD parameter, then you can calculate S parameter. So what we will do, they will ask the question like this. What they will ask? They will ask the question, they will give the Z parameter. They will give Z parameter. Try to understand. They will give Z parameter. Yes, sir. So what you will do with Z parameter? First of all, you will try to find out ABCD parameter. First of all, you will try to find out ABCD parameter. And if you will find out ABCD parameter, then you will find out S parameter. Then you will find out S parameter. Yes, sir. So this is network. This is network, and this will be EMFT. So this question will be network plus EMFT. So they will give Z parameter and they will ask S parameter. You can calculate. They will give Z parameter, they will ask S parameter. You can calculate. Similarly, so you can calculate. So they will give Z parameter, they will give Y parameter, they will give in exam H parameter. So you can you can find out ABCD parameter by network concept, network theory concept, and then after you can find out S parameter. This is the process. In this way they will ask the question. So this will 2 marks question, 1 marks for this conversion and 1 marks for this conversion. So this is the formula. If you know ABCD parameter, you can find out S parameter. Second way is they will ask what? They will give S parameter. They will give S parameter. Yes, sir. Then you will find out ABCD parameter. Yes, sir. And then they will ask Z parameter. They will ask Z parameter. So S parameter to Z parameter, S parameter to Y parameter, S parameter to H parameter. You can find out easily. You can find out easily. So this is the way they will ask the question. They will ask the question. So they will ask from Z parameter to S parameter, or ABCD parameter to S parameter, or Y parameter to S parameter, or H parameter to S parameter, or ABCD parameter to S parameter. Or they will ask the question S parameter to Z parameter. So S to ABCD, then Z parameter, S to ABCD, then Y parameter, S to ABCD, then H parameter. In this way you can find out the formula. In this way you can find out the formula. Okay. Then what you will do? There is a question. One question is series network. Another question is shunt network. So they will ask series network question. They will ask shunt network question. So in exam they will ask. So first of all is series network. What they will ask? Series network. Yes, sir. So I am trying to find out this point. Series network they will try to find out. Yes, sir. So series network, in this way they will connect and they will ask the question. They will ask the question. How they will ask the question? They will connect here a impedance Z, and the transmission line has characteristic impedance Z0. This one has Z0, and this is the second wire of the transmission line. Yes, sir. They want to know what is the value of S parameter. So first of all, what you will do, They want to know the value of S parameter. I will write it down later after deriving. After deriving the equation, I will write it down. So this is S parameter. Yes sir. You can find out easily. How you can find out? So it is very easy. It is very easy. First of all, what you will do? First of all, what you will do? That you know ABCD parameter for this network. If you don't know, just derive it. If you don't know, just derive it. Actually, I didn't remember that. So I will derive this I1, I2 and V2. Yes sir. So what is first equation? First is I1 is equal to I2. Yes sir. Second is you can apply KVL. So V1 plus V1 is equal to V1 plus I1 into Z, I2 into Z or I1 into Z. So I1, I2 are equal. So I2 into Z plus V2. Yes sir. And you know this is the two-port network. This is a two-port network. So for this two-port network, what is the value for V1 and I1 and I2 and V2? I2 I am taking outside. So what is the equation for this one? Equation for this one is V1, I1 and, sorry, you can write it like this also, V1 AV2 plus BI2 plus I1 is equal to CV2 plus DI2. Yes sir. You can compare. You can compare. This is equation 1, 2, 3 and 4. This is transmission line matrix. Yes sir. So you can compare and you will get the answer. So from 1 and 2, 1 and 4. From 1 and 4, what will be the answer? From 1 and 4. 1 and 4, what will be the answer? So from 1 and 4, you will get V2, there is no term of V2, so C will be 0. There is DI2, so DI2 is our, so you can compare, D will be 1. So you, after comparing, you will get C is equal to 0, D is equal to 1. Yes sir. Then after comparing from second and third, what you will get? From second and third, what you will get? You will get from second and third A V2 or here V2. So A will be 1. A will be 1. And here B I2 and here I2 into Z. So B will be Z. Yes sir. So you have got transmission line matrix. That means A is equal to how much? 1. B is equal to Z. C is equal to 0 and D is equal to 1. So this is ABCD matrix for series network. If you remember, you don't have to do this all things. You just write it down, you will get the answer. What? 1Z01. If you got the answer, then you will apply this formula. Then you will apply this formula. What is the formula here? This is the formula. This is the formula. You will apply, you will get. So what is ABCD? I will write it down here only. A is 1, B is Z, C is 0, D is 1. Yes sir. So I will write it down here. What is A? A is 1, B is Z, so Z by Z naught. C is 0, so 0, and D is 1, so minus 1. Divided by 1 plus Z by Z naught minus 0 plus 1 plus 1. It will be how much? It will be Z upon 2Z naught plus Z. 2Z naught plus Z. Yes, easy. From S2 to you can also calculate. From this one you can also calculate. AD minus BC. So AD is 1, BC is 0. So AD minus BC is 2. So AD is 1. 1 into 1 and 0 into Z and then after 1 plus Z by Z naught plus 0 plus 1. So you will get 2Z upon Z0 upon Z0, 2Z0 plus Z, 2Z0 plus Z. Yes sir. Then you will put here also 2, yes sir, 1 Z by Z0 plus 0 plus 1, so you'll get 2 Z0 upon 2 Z0 plus Z. Yes sir. And what is the condition for this one? So A is -1, so -1 Z by Z0, C is 0, D is 1, divide by 1 Z by Z0 plus 0 plus 1, so it will be Z by 2Z0 plus Z. Yes sir. So we have calculated what? We have calculated S parameter in terms of Z, in terms of Z. It is very easy. It will be very easy. If you want to remember the formula, you can remember. If you want to derive it. First find out ABCD, then apply this formula, you will get S parameter. Easy, very easy. So S parameter is Z, 2Z0 plus Z, and 2Z0 divided by 2Z0 plus Z, and 2Z0 plus 2Z0 plus Z, and Z 2Z0 plus Z. So this is a very easy question. This is a very easy point. So they will give 50 ohm, 50 ohm. You can find out the value. 50 ohm, 50 ohm. What will be the value? 50, 150, 1 by 3. 100, 50, 150, 2 by 3, 2 by 3, 1 by 3. So if they will give 50, 50, you will give the answer. You will give easily answer. Answer very easily. So I will take one example. I will take one example. So what is the example? I will take the value and then I will try to find out S parameter. So they will give this one as 25 ohm, this one as 25 ohm, Z0 as 50 ohm, Z0 as 50 ohm. Yes sir. Then you have to find out only S parameter. What is the S parameter? So 25 divided by 50. So 50 plus 25. So 25 by 75. 125. This one is 100 by 125. This one is 100 by 125. Just put the value, you will get the answer. 25 by 125. Yes sir. 4 by 125, 1 by 125, you will get the answer. You will get the answer. What is the answer? So S parameter will be 1 by 1 by 5, 4 by 5, 4 by 5, and 1 by 5. Yes. This is our S parameter. This is our S parameter for series network. So you can easily find out the value. So they will ask what is S parameter for this network. You can easily give the answer. This is one example. Then we have series network. Then we have shunt network. Then we have shunt network. So you have to give answer for shunt network. Shunt network ask in GATE exam. They will ask again, but they will ask this time series network. So we have shunt network. For shunt network, what we will do? This one is our shunt network. A transmission line, yes sir, of Z0. A transmission line of Z0, and there is a, in between them there is a Z. In between them there is a Z. So we have to find out S matrix for this network. We have to find out S matrix for this network. So what we will do? First of all, we will try to find out the ABCD parameter. First of all, we will try to find out the ABCD parameter. This is Z. Yes sir. This is Z. This is V1. This is V2. Yes sir. V1, V2. So we have a current. We have current I1. Yes sir. This is I2 is outward current in ABCD parameter. So I2. So current in this network is I1 minus I2. Current in this network is I1 minus I2. Yes, sir. Then apply KVL. If you apply KVL, V1 is equal to. So first of all, you will get V1 is equal to V2. Parallel condition. Second case, you will get apply KVL here. Apply KVL, here only. Apply KVL in this network. You will get easily. So what will be the answer? So I1 minus I2. I1 minus I2 into Z is equal to V2. Yes, sir. So you can solve it. You will get the answer I1 minus I2 into V2Z. So I1 is equal to V2 upon Z plus I1 plus I2. So you will get I1 I2. You will get V1 V2. Yes, sir. From first, this one is second equation. And you know ABCD parameter. V1 is equal to AV2 plus VI2. This is third equation. And I1 is equal to CV2 plus DI2. This is fourth equation. Yes, sir. So from first and third, what you will get? V1 V1, A V2. So A is 1, V is 0. So A is 1, V is 0. And second one, from which part? From which part? You have from first and second, then you have second and fourth. Second and fourth. C is equal to 1 by Z. C is equal to 1 by Z. D is equal to 1. So you know that the ABCD matrix of this equation. What is the ABCD matrix? So ABCD matrix will be 1, 0, 1 by Z, 1. This is the ABCD matrix for this shunt network. So 1, 0, 1 by Z and 1. Then apply this formula. You will get this formula. Applying this formula, you will get the answer. Then apply this formula. So our ABCD is how much? Our ABCD is how much? First of all, think like this. So A is how much? 1, 0, 1 by Z and 1. So B is 0, A is 1. You will put and you will get the answer. So A is equal to 1, B is equal to 0, A is equal to 1, B is equal to 0, C is equal to 1 by Z and D is equal to 1. So denominator will be same in all cases. Denominator will be same in all cases. So denominator will be same. Yes, sir. And C is 1Z. So what will be? Z0 upon Z. Minus 1. Then 1 plus 0. And second one is ABCD. So 2. AD minus BC. So AD is 1. BC is 0. So 1 into 1. And B is 0. 1 by Z. So it is 2. This one is 2 and this one is minus 1, 0, minus Z by Z, Z0 by Z. C is 1 by Z and plus 1. So this one and this one will be cancelled out. This Z will be cancelled out. So you will get minus Z0 upon 2Z plus Z0. This one is 2Z upon Z plus Z0. 2Z plus Z0. 2Z plus Z0. Yes, sir. And this one is 2Z upon 2Z plus Z0. And this one is 2 minus Z0 divided by 2Z plus Z0. So this is ABCD matrix. This is S parameter in terms of Z for shunt network. So you have calculated for shunt network, you have calculated. So minus Z0, 2Z plus Z0, minus Z0, 2Z plus Z0, and you will get this one also. And this one is 2Z, 2Z plus Z0. Yes, sir. So you will get S matrix for this network, S matrix for this shunt network. So series network, you have got S matrix. Shunt network, you have got S matrix. So just you have to do summary and write down in 2-3 pages the S parameter. You will get everything. Okay. So this is S matrix in terms of S parameter. S matrix in terms of S parameter. Then there is example. There is a example. Example means this question asked in GATE exam, ask in GATE exam, ask in ISRO exam. Everywhere they have asked. This is a very good question. This is a very good question. So this question is asked in ISRO exam. This question is asked in GATE exam. Everywhere they have asked. How much they have given? 50 ohm. And how much Z0 is given? 50 ohm. Z0 is given 50 ohm. They are asking what is S parameter. So S parameter will be, formula will be minus Z0, 2Z upon plus Z0, and this one is Z, 2Z upon Z0, 2Z plus Z0. Yes, sir. And you will calculate like this only. So what you will get, if I will put Z, so it will be minus 1 by 3, it will be 2 by 3, it will be 2 by 3, it will be 2 by 3, and it will be minus 1 by 3. So this is the answer. Formula based question asked. So they have asked formula based question. It is very easy. It is very easy to find S parameter. Then one question also asked for two-port network. For two-port network, that means for two-port network means transformer. They have asked the question for transformer. Yes, sir. For transformer they have asked. Yes, sir. This is B1. This is I1. And this is I2. And this is B2. The number of turns of this one is N1 and number of turns for this one is N2. Yes. So what we'll do? What we'll do? We will do just first of all, what is the ratio of B1 by B2? So B1 by B2 is N1 by N2. So B1 is equal to N1 by N2 into B2. Yes. This is equation 1. Then I1 by I2 is equal to N2 by N1. You know from transformer. So I1 is equal to N2 by N1 into I2. N2 by N1 into I2. Yes, sir. Then B1 is equal to A V2 plus B I2, and I1 is equal to C V2 plus D I2. This is equation 3. This is equation 4. By comparing, you will get the answer. By comparing, you will get the answer. So what is the ABCD matrix? So ABCD matrix will be, A is how much? A is N1 by N2, and B is how much? 0. C is how much? 0, and D is how much? N2 by N1. Yes. So you have calculated ABCD matrix for transformer. Then you have to calculate S matrix for transformer. Then you have to calculate S matrix for transformer. How you will calculate? It is very easy. How you will calculate? It is very easy. Very easy, because AB term is 0. AB term is 0. Yes sir, it's very easy to calculate. So what we'll do, A is N1 by N2, B is 0, C is 0, D is N2 by N1, D is N2 by N1, A is N1 by N2, B is 0, D is, C is 0, and this one is N2 by N1. Yes sir. What you will do, the denominator will be same for all cases. The denominator will be same for all cases. So I will write same denominator. Then we have minus N1. This one is 2. AD. A into D is 1. And B into C is 0. So it will be 2. This one is 2. This one is minus N1 by N2. 0, 0 plus N2 by N1. So the ratio will be, what will be the ratio? Ratio will be very easy to understand. So ratio will be very easy, very useful. So what is the ratio? So ratio will be N1 square minus N2 square. N1 square minus N2 square. N1 square plus N2 square. N1 square plus N2 square. Denominator will be same for all cases. Denominator will be same for all cases. So it will be same. Then after it will be 2N1 N2. And this one is also 2N1 N2. And this one is N2 square minus N1 square. So you have calculated the value of S parameter in terms of which parameter? S parameter in terms of number of turns. So for transformer you have calculated. So for transformer S parameter will be, N1 square minus N2 square divided by N1 square plus N2 square. Yes sir. 2N1 N2 divided by N1 square plus N2 square. Yes sir. Then what you will do? Nothing. This one is S22. This one is S12. Yes sir. And S22 will be changed by minus sign. So 1 N2 1. So this is the S parameter for transformer, S parameter for series network, S parameter for shunt network. You have calculated everything. Then what we will do? Then I will give some assignment. I will not discuss in the class. So I will give just assignment. You have to do yourself by yourself. That means what is the S parameter for this network? What is the S parameter for this network? This is series shunt. Yes sir. What is the S parameter for this network? What is the S parameter for this network? This one is shunt series shunt. Yes sir. So you have to find out S parameter for this network. So it is self-assessment course point. It will be self-assessment point. I will just hint it out. You can do yourself also. So this one is Z1 and this one is Z2. So ABCD I will help it out how you will calculate. So ABCD is very easy to calculate. How? ABCD for this one is 1 Z 0 1 and ABCD for this one is 1 0 1 by Z and 0 1 by Z and 1. So you will calculate ABCD, then you will calculate S parameter. If you calculate ABCD, then you calculate S parameter. So this is self-assessment. Then you can find out ABCD S parameter. This is self-assessment. Self-assessment. it is a self-assessment type question. Yes sir, it is a self-assessment type question because this question may be asked in the GATE exam. So first of all find out ABCD, then find out S parameter. Then again we have shunt series network. It is also a self-assessment question. It is also a self-assessment question. So how we will solve this? I will still help you to find ABCD network. It is self-assessment question. This one is Z1, this one is Z2. So ABCD matrix for this one is, ABCD matrix for this one is, because they are cascaded, so I can apply this one. So ABCD network for this one is Z1 is 1, 0, 1 by Z1, 1. And ABCD network for Z2, 0, 1. So you will find out ABCD matrix, then you will find out S matrix. So these all question may be asked in GATE exam. They will ask the question like this also. They will give some S parameter and they will ask the question. They will give S parameter and they will ask the question. So you have to find out that question also. So if S parameter is given and you have to find out ABCD, you will apply this formula. If S parameter is given and you have to find out ABCD, you will apply this formula. It is very easy. So it is very easy. S11, S12, everything is given. Just put down the formula, you will get the answer. Okay. So our topic is over. So our S parameter is somewhat over. Only one point is left. That means what is insertion loss and everything. So I will do 10 minutes in 10 minute tomorrow class, and then after we will do the question. So here what we have done, S parameters. Tomorrow we will do the questions of S parameters. All type of questions in S parameter. So tomorrow we will do the question of S parameter. You can download this Unity app. It is very useful for you, and you can go through because it is very useful, and you can go through this channel Sonu Sir PW. You may ask any question to me. Okay. Thank you very much. Thank you. We will meet it again.